All right. Hello, everybody. We're going to do a little bit of a quadratics review today. Most of the stuff you should have learned in Algebra 2, maybe before then. We're going to start by talking about solving quadratic equations by using the greatest common factor. So don't forget that the greatest common factor, or GCF, is the highest factor that will divide into the expression. So remember that a GCF can be a constant, it can be a variable, it can be a combination of both of those. So for our first example, we're looking at 5x squared minus 10x. So if I look at my two terms here, my greatest common factor between my constants 5 and 10 is going to be 5. My GCF between my variable terms, x squared and x, is going to be x. So I'm going to take out a 5x. And then what I'd be left over with if I take a 5x out of my first term, I'd just be left with an x. And then I'm going to bring down my minus, and I'd be left with a 2 in my second term. And since we are solving an equation, we can't forget to bring down the equals to 0. And then from here, once we have our factors, we're going to use our zero product property, which tells us that we can separate each of our terms and set them each equal to 0, and then solve them each in their own equation. So I can divide this one by 5, and this is going to give me an x value of 0, which is my first solution. And then I can add 2 to this one, which is going to give me x equals 2 for my second solution. The next one's a little bit different because if you notice the two terms aren't on the same side of the equation, first thing I'm going to do is I'm going to bring everything to the same side. I'll bring the 14x over to this side to make it positive, just to make things a little bit easier. So I'll add 14x to both sides. That'll leave me with 4x squared plus 14x now is going to be equal to 0. And then between these two terms, 4x squared plus 14x, my greatest common factor between 4 and 14 is going to be a 2. And my greatest common factor between x squared and x is going to be an x. So I'm going to take out a GCF of 2x. That's going to leave me with a 2x, and then bring down the plus between, and a 7. Bring down my equals to 0. And now that I've got my two factors, I can go ahead and use my zero product property to set them each equal to 0. So again, this side I'm just going to divide each side by 2. This is going to give me an x value of 0. This one I have to do in a couple steps. First one, I'm going to subtract 7. So I'm going to get 2x equals negative 7, and then divide each side by 2. So my x value ends up being negative 7 over 2. All right, so that's GCF, or greatest common factors. The next thing we'll review is solving using square roots. And this happens when you only have a squared variable term and a constant term. So meaning you have one term that's got like an x squared in it, and then you've got one term that doesn't have any variables in it. And this solving is a little bit different because what you can do with just a squared term and just a constant term is you want to get the squared term by itself on one side of the equation. So for this one, I'm going to add 25 to get the 16x squared by itself. So that gives me 16x squared is equal to 25. And then I want to get the x squared by itself. So I'm going to go ahead and divide each side of the equation by 16, which gives me x squared equals 25 over 16. So this gives me this expression. So then to undo the power of 2, I want to go ahead and take the square root of each side. So on this side, the square root and the power of 2 undo each other. But on this side, don't forget that when we do take a square root, we have to have a plus or minus to get both of our solutions. So that means that what I can do here, because both of these are perfect squares, I can kind of like split up the square root into a square root of 25 in the numerator and a square root of 16 in the denominator, which actually allows me to simplify this pretty simply, because my numerator ends up being 5, my denominator ends up being 4, and then we want the plus or minus that indicates that we have two solutions, because remember that says one of our solutions is positive 5 over 4, and then the other solution is negative 5 over 4. All right, so kind of same idea for number 4, except this one we don't have to move anything to either side because I have the squared term over here by itself, and then I have the constant term over here by itself. So I want to get the x squared alone. So I'll go ahead and divide each side by 3. And that's going to give me x squared is equal to 8. And then I want to take the square root of each side, which is going to give me x is going to be plus or minus the square root of 8. But for these, we always want to make sure that our answers are in simplest form, meaning simplest radical form. So for this one, I can actually take the square root of 8 and break it down into smaller pieces. If I use the perfect square method, I know that there's a perfect factor of 4 that goes in. So I end up with plus or minus the square root of 4 times the square root of 2. And I can take that square root of 4. So my simplest radical form ends up being 2 root 2. Or if you prefer the factor tree method, you can break down 8 into 2 times 4. And then you can break down your 4 into 2 times 2. So we end up getting one pair of 2. That's the 2 that comes out. And then we have the 1, 2 left over. That's the one that stays in. All right, a couple more like this. Example 5 is a little bit, again, different because we have this 3 over 2 in front of our x squared. We could divide each side by 3 over 2, but the same thing as dividing by 3 over 2 is multiplying by its reciprocal. So instead, I'm going to actually go ahead and multiply each side of the equation by 2 over 3. That undoes all of the fractions on the left-hand side, so I'm left with just x squared. And then 48 times 2/3 gives me 32. So x squared equals 32. Now that the x squared is by itself, go ahead and take the square root. That's going to give me x equals plus or minus the square root of 32. And again, I want to get this in simplest radical form, either using the factor tree or the perfect square method. I believe that is 16 and 2 that works there. So I can go ahead and take the square root of 16. That's a 4. And then the 2 stays on the inside. So x is plus or minus square root, or plus or minus 4 root 2. Okay, last one over here. We have negative 7x squared plus 9 equals 0. So again, I want to get the squared term by itself. So I'm going to go ahead and subtract 9 on both sides. That's going to give me negative 7x squared equals negative 9. And then to undo this negative 7, go ahead and divide each side. So that's going to give me x squared equals positive 9 over 7, because these two negatives are going to give me a positive. So then I can go ahead and take the square root here. This one is a little bit kind of like example 3 when we had the square root here. What I can do is I can go ahead and split up the root into a square root of 9 over a square root of 7. Square root of 9 is just 3. I can't take the square root of 7. I would just have to leave that because that's not a perfect square. But I would need to rationalize this because I can't leave that root in the denominator. So if we rationalize that, our solutions here end up being x is equal to plus or minus 3 root 7 in the numerator, and then 7 in the denominator. And again, don't forget your plus or minus on that. Okay, so that's kind of 2 of the methods for solving. Our other method that we spent a lot of time on Algebra 2 was solving by factoring. So remember that when you're solving by factoring, you want to get your terms all on one side of the equation with a 0 on the other side. But if there is a greatest common factor, once we get it into the form with the 0 on one side, remember that we want to get rid of the GCF or factor it out first. So example 7 is pretty straightforward. This is just a coefficient of 1 here because there's a 1 in front of the x squared technically. So if there's a coefficient of just 1 on your x squared, what you're really looking for when you're factoring this is you're looking for numbers that are going to multiply to your last number but add up to your middle number. So I'm looking for 2 numbers that multiply to 40 but add to negative 14. So two numbers that multiply to 40 but add to negative 14. These two numbers would be, I believe, negative 10 and negative 4. Because negative 10 times negative 4 gives you positive 40, but if you add negative 10 and negative 4, that gives you a negative 14. So these two numbers are the numbers that go on the inside of your factor. So in each of the factors, we're just going to put an x, again, because the leading coefficient there is 1. And then I'm going to put a minus 10 in one of the factors, and I'm going to put a minus 4 in the other one. And then from here, this is similar to what we did on the front side, where we said when we had the factors, we could split them up and set them each equal to 0. So I'm using my zero product property. So I'm going to take x minus 10, set that one equal to 0, and then I'm going to take the x minus 4 and set that one equal to 0, and then solve each one of these. First one by adding 10. So I get x equals 10. Second one by adding 4. So I should get x equals 4. Okay, next one's a little bit different because not all terms are on one side of the equation. So I'm going to bring the 120 to the other side by subtracting it. So I can get one side equal to 0. So I get 3x squared plus 9x minus 120 is equal to 0. But then I'm noticing that the coefficients here all have a common factor of 3. So what I'm going to do is I'm going to take out the GCF that's here. So 3, open up my parentheses, bring down my equals to 0. If I take a 3 out of the 3x squared, I'm left with x squared. If I take a 3 out of a 9x, that's going to give me a 3x. And then when I take out a 3 from a 120, I believe that gives me 140. I'm sorry, 40, not 140. And if there is just a constant here, meaning no variable in front of the GCF, what we can do is we can actually divide that factor out so that we get rid of it so it doesn't mess us up when we're trying to factor. But that's only if there's no variable attached to this can you do that. So we get x squared plus 3x minus 40 equals 0. So now this one looks pretty similar to this one where I have a coefficient of 1 here. So really all I'm looking to do here is to, again, look for numbers that multiply to this last value but add to the middle value. So I'm looking for numbers that multiply to negative 40 but add to positive 3. So numbers that multiply to negative 40 but add to a positive 3, I think is a positive 8 and a negative 5. Because positive 8 times negative 5 gives us negative 40, but positive 8 plus negative 5 gives me a positive 3. So these are going to be, again, the two numbers that I want to put on the inside of the factors. So when I set up my factor, again, my leading coefficient here is 1. So I'm just going to put an x in each one of them. One of them is going to get a plus 8. The other one's going to get a minus 5. And then I can use my zero product property. Set each one of them equal to 0 and then solve from there. So I'm going to subtract 8 from the first one. That's going to give me x equals negative 8. Add 5 to the second one. And that's going to give me x equals positive 5. All right, the last two examples are different because these two are going to have leading coefficients on the x squared that we're not going to be able to get rid of by a GCF process. So there's a couple different ways to do this. You can always use guess and check. Some people don't like guess and check because they have to check too many numbers and it gets a little bit tedious. So the way that I like to do it is by factoring by grouping. So the first thing that you want to do if you're noticing, again, all of our terms have to be on one side with one side equals 0. If that's happening, I'm going to check to see if there's a GCF here, which actually it doesn't look like because I don't have any numbers that divide into all three of these evenly. So if I don't have a GCF, I'm going to go ahead and I'm going to multiply the number that's in front of the x squared times the constant. So I'm multiplying 6 times 15, which gives me 90. So what I'm looking for with this 90 is I'm looking for two numbers that are going to multiply to 90, but are going to add to my middle term. So numbers that multiply to the product that we just got, but add to the middle number of negative 19. And I believe the two numbers that work here are going to be negative 10 and negative 9. Because negative 10 times negative 9 gives me 90, but negative 10 plus negative 9 gives me negative 19. So once I find these two numbers, the thing that's different about this process is I have to carry down in my process the first term and the last term, and equals to 0. And what I'm going to do is I'm going to split up this negative 19 as these two numbers being either added or subtracted together depending on their signs. And I'm going to group them with one of these two terms depending on which they have common factors with. So I think I'll just group the negative 10 by the 6x squared. And again, on that number, I'm going to put an x because we're splitting up this term. And then I'm going to put the negative 9x next to the 15. And I really haven't changed this quadratic because if I look here in the middle term, negative 10x minus 9x adds to negative 19. The only thing I've done is literally expand this polynomial to make it a little bit longer, because now I have 4 terms. And with 4 terms, now we can go ahead and split up the first 2 terms and the last 2 terms and take greatest common factors out of each pair. So out of 6x squared and a negative 10x, I can take out a 2x. And if I take out a 2x out of a 6x squared, that leaves me with a 3x. If I take a 2x out of a minus 10x, that's going to give me a 5. And once I'm done with the first pair, I'm going to close the parenthesis. And then, because there's a minus here in the middle, I'm going to take out a negative. And then it looks like the greatest common factor between 9x and 15 is a 3. I'll open up my parentheses, bring down my equals to 0. If I take a negative 3 out of a 9x, that leaves me with a 3x. And then if I take a negative 3 out of a positive 15, I'm actually left with a minus 5 here, because if I distribute the negative 3 back into the negative 5, that's where the positive's coming from. And the thing with factoring by grouping is I know that I've done something correctly if I have the same factor here and here, which means that in my next step, one of my factors is the 3x minus 5, because this matches this. One of my factors has to be that. The other factor is going to be the stuff that's left over on the outside. So I still have a 2x and a minus 3, and that's what's going to make up my other factor. And then I'll bring down my equals to 0, and then I can go ahead and use my zero product property. So take 3x minus 5, set that equal to 0, take 2x minus 3, set that equal to 0, and then do what I need to do to solve here. So first one, I'll add 5. So I get 3x equals 5, and then I'll divide by 3. So x will be equal to 5 over 3 as my first solution. Second one, go ahead and add 3. I get 2x equals 3. Divide each side by 2. X is going to be equal to 3 over 2. All right, so let's look at one more example like that one. The first thing I'm noticing about this one, though, is that I have terms on both sides. So what I'm going to do is I'm going to leave the 5x squared where it is because it's a positive value. And I'm going to bring these two terms over to the other side by subtraction. So I'm going to subtract a 4, and I'm going to subtract an x. And I'm going to rearrange this so that it's in standard form. So I'll write the 5x squared, then I'll write the minus x, then I'll write the minus 4. And then I'll bring down now this side is equal to 0. So again, if I'm looking at these terms, I'm noticing that I don't have a greatest common factor between a 5x squared and minus x and minus 4. So I'm going to go ahead and use my factoring by grouping. So I'm going to multiply my a times my c. So I'm multiplying 5 times negative 4, and that's going to give me a negative 20. And what I'm going to do is I'm going to look for numbers that multiply to negative 20, but add to my middle term. So I'm looking for numbers that multiply to negative 20, but add to my middle term, which is actually going to be negative 1, because my coefficient on the x is technically negative 1. So if I'm thinking about what numbers are going to work here, it looks like a negative 5 and a positive 4 are going to work, because negative 5 times positive 4 gives me negative 20. But if I add negative 5 and positive 4, that's going to give me the negative 1. So again, the process here is to bring down the first term, the 5x squared, bring down the last term, the minus 4, bring down the equals to 0, and then I'm going to use these two numbers to just split up this middle term x. So I'm going to group the minus 5x with the 5x squared, and I'll group the positive 4x with the minus 4. So again, I'm not changing this polynomial, because if I were to combine these back together, that's where the negative 1x is coming from. But I do want to now group these together in pairs. And I'm going to just look at these two pairs. I'm going to take the GCF out of each one of them. So 5x squared minus 5x, my GCF is 5x. So if I take a 5x out of 5x squared, that leaves me with an x. Bring down my minus. If I take a 5x out of a 5x, I should be left with 1. And then 4x minus 4, it looks like my GCF here would be a plus 4. Bring down my parentheses, bring down the equals to 0. So I'm taking a 4x out of, or sorry, a 4 out of a 4x. That leaves me with an x. Bring down my minus. Take a 4 out of a 4. I should be left with 1. And again, these should match. So that means that my first factor is an x minus 1. My second factor is the stuff that's left over on the outside, so a 5x plus 4. And then I can go ahead and split these up to use my zero product property. So x minus 1 equals 0, and 5x plus 4 equals 0. And then I can go ahead and solve. So add 1 to this one. My first solution is x equals 1. Subtract 4 from the second one. Get 5x equals negative 4, and then divide by 5. So x is equal to negative 4 over 5. All right, so now it's your turn to try the homework. Let me know if you have any questions.